Okay, now we're going to find the equation of the line. The equation is y equals mx plus c. That's the general equation of any straight line. Probably best if I show by doing the first example. It's the line going through the point 2 minus 5 and having a gradient of 5. We have to come up with the equation of the line. Now to do that, I'll just write down the question. So we have 7g, question 1a, we've got to go through the point 2 minus 5 and we've got to have a gradient of 5. Now just to illustrate what we're actually doing, let's actually plot this. So here is your y-axis and here is your x-axis. Now 2 minus 5 means you go across 2 and you go down 5. 1, 2, 3, 4, 5. That point there is 2 comma minus 5. Now if we want a gradient of 5, that means it's really 5 on 1. And I do that because that's the rise and that's the run. So if you run across 1, so you go across 1 and you go up 5, which is all the way up to here, that's our triangle, which means this is the gradient of 5. So this represents the line through 2 minus 5 having a gradient of 5. Now how do we get the equation of that line? You write it like this: y equals mx plus c. Now the m is the gradient, so we really say y equals 5x plus c. The m is always the gradient or the slope. The only thing we need to find now is the c value, and the c value is where it cuts the y-intercept. The y-intercept, it looks like, if I extend this y-axis down, it looks like it's going to hit somewhere down here. We don't know what that is because my graph isn't accurate, and so we need a better way of finding out what the y-intercept is. So to do that, we have to substitute a point in, and we've got one point that lies on the line. So if it lies on the line, it satisfies the equation. So we're going to sub in 2 minus 5. Now when we sub it in, that's substitute, the minus 5 is the y, so we put minus 5 where y is. I'll put it in brackets to say I'm substituting it for y. The 5 stays as 5, but the x is replaced by the x coordinate, which is 2. So the x value goes where the x is. And now we can work out c. So solving this equation, we have minus 5 equals, that means 5 times 2, which is 10, plus c. Now we need to get c by itself. To get 10 onto the opposite side, we use the opposite operation. Opposite of plus 10 is minus 10, so it's minus 5 minus 10 equals c. Minus 5 minus 10 is minus 15. That now tells us that the y-intercept is minus 15. We couldn't have got that using this because it wasn't that very accurate. So now we can say the equation is y equals 5x minus 15. That's the equation of the line. It's very useful having this equation. I can show you on the graphics calculator. We'll remember that 5x take 15. So if I bring up the graphics calculator and I click on y equals, I'll just clear from the last thing. I'm going to switch off that plot sitting up there, so everything's switched off. I'm now going to put in 5x minus 15. And we're going to have a look at what this graph looks like. We're going to, we could set the window scale. So if I press window, we want to go from the x minimum, that's the x scale, we could go from minus 10 up to 10, that's on the x-axis. On the y-axis, we will go from minus, if we go from minus 10, we won't pick up that y-intercept, so we want to get at least 15 in, so we'll put start minus 20, and we'll head up to 10 on the y-axis. Now if I press graph, we can see that it's cut through minus 15. It has a slope of 5. Just to see that 2 comma minus 5 lies on that line, we can easily do this. Second calc, which is calculate a value, and we'll say what is the value when x is 2. Press enter, and it says it's minus 5. That's our point. 2 minus 5 lies on that line. You can actually press the trace key and you can go up and down that line like this, getting other sets of points that lie on that line. Okay, so that's the first one. One part A is done. You try the rest in that exercise in question 1. Just pause it and have a go, and then come back to have a look at the answers. Okay, here are the answers to 7G1, all there. That's what 1, A, B, C, D, E, F. Now we'll just jump to question 3, just to show a different way it can be asked. This is find the equation of a line passing through 2 points. They don't give you the gradient, but we can work out the gradient. So I'll do that first one. So the first point is A, 1, 5, and the second point is B, 4, 8. First of all, we need to work out the gradient or the slope. I'll just call it M. That's what we call for slope. That's y2 take y1 on x2 take x1, but that we learnt from the last lesson. I'm going to call B.2 A.1. So y2 take y1 on x2 take x1. Now the y2 is 8, the y1 is 5, the x2 is 4, the x1 is 1. So 8 take 5 is 3, 4 take 1 is 3, 3 divided by 3 is 1, so our slope is 1. We can now say that our equation is y equals mx plus c, but because m is 1, we can now say it's 1x plus c. Usually when we have 1x, we just replace it with x, because 1 times x is x. Okay, now we have to work out c. We're going to sub in a point. We'll sub in, I'll choose 1, 5, because they're smaller numbers. Doesn't matter which one you use. The 5 is the y, so that goes where the y is. The 1 is the x, that goes where the x is. Now we have to get c by itself. We have to take 1 over the other side. So 5 take 1 is 4. So therefore our equation is y equals 1x plus 4. That's our equation. Okay, now you try the rest of 3 and then come back to see the answers. Now the solutions at the back are all in general form, so rather than trying to convert your intercept form equations into general form, I've given the answers here all in slope-intercept form. So here's the answers to 3A, B, C, D, E and F. D and E have fractions involved with them. If you're struggling with fractions, you'll probably need to get some extra help for D and E. Now, if you're interested to know how I got the slope-intercept form from the general form, I'll explain that with the first example. So what they had written down in the back of the solutions for 3 part A was x take y equals minus 4. That's what we call general form. The general form starts off with the x, followed by the y, followed by the number. We want it in slope-intercept form, where we want y by itself on the left-hand side. To get y by itself, we have to get x over the other side. At the moment there is a plus x. Opposite of plus x is minus x. So we're like this. Now we have to get rid of the minus. To get rid of the minus, we could multiply everything through by minus 1. Another way of thinking of it is that minus 1 really means minus 1 times y. The opposite of timesing minus 1 is dividing by minus 1. So we're going to divide everything by minus 1. Either way, you lose the negatives in everything. And so y equals x plus 4. Now that is called slope-intercept form. And the reason why that's called slope-intercept form is because the first number is the slope, the second number is the intercept. It's in the form y equals mx plus c. Both are the same. I prefer the slope-intercept form. It's more useful in the graphics calculator because you can put it straight into the y equals and graph it. But you should get it, or by year 11 be able to convert between general form and slope-intercept form.